Okay, I'm back with another example, and this is a good one we're going to be able to riff on a little bit. The setup's a bit complicated, so I'll go slowly here. I got this 1 kilogram box. It's not moving. I included that at the end. VI is 0. Okay, it's pushed up the ramp with a force of 5 newtons, parallel to the ramp. Okay, so we're pushing it up 5 newtons. The ramp is 5 meters diagonally, 2 meters vertically. Assuming the ramp is frictionless, we're going to determine its speed at the top. Okay, so if we have this force, no friction, how fast is it going at the top? Now, what's really nice about using work and energy here is that there's not going to be any trig. Okay, we could have done this in the dynamics unit with a net force, and, well, maybe you guys are having flashbacks of all those free body diagrams, boxes on inclines. We're going to be able to do this one with absolutely no trig, and we'll riff on it. Like I said, we can add friction later. It's not actually much more difficult with friction. First, let's find the work we do on the box. Okay. The force and displacement are parallel, so we don't have to worry about an angle. The force was 5. For displacement, well, the force pushes it all the way up the ramp. The displacement is going to be 5 meters up the ramp. Work is not a vector, though, so we don't need to include that at the end. Okay. So we did 25 joules of work on this box, which means up here, its mechanical energy is going to be 25 joules, because this is how much mechanical energy we gave it. Remember, work is equal to the change in mechanical energy. When it was down here, its speed was 0. It's at the bottom. Its energy is 0. Okay, so it went from 0 to 25. So 25 has to be EP plus EK, which is mgh plus half mv squared. Okay, we know h. H is 2. We know mass and g. The only thing we don't know is v, which is what we're looking for. So let's work our way through this. Okay, so I'm just quietly doing all my algebra here. So I'm going to get 5.38 times 2 square root will be my v. Let's find out what we get. I get 3.28 meters per second. Okay, I'm trying to sell you on using energy. Usually when I've got kinematics questions or even dynamics questions, I try to solve them with energy. It's a nice way of thinking about physics.